An alternate way for making functions, rather than making a separate M file like we did in the previous two examples, is for small functions, and usually ones that only have one output to them, we can make what's called an inline or an anonymous function. So if we take, for example, we want our function to be x cubed minus 8 times the quantity x minus 3. Since it's a very simple function, and we'll get later into much more complicated functions, but for very simple functions we can use this type of syntax. So let's say I want to make my function called myFun for right now. This is going to take one input argument, which I'll call x. So over here at the @ sign, I have to include what my input arguments are going to be. In this case, just x. So it's going to be x cubed minus 8 times quantity x minus 3. And for this cell, I want to clear everything I had going on previously. So if I run the cell, we see that I have myFun and its definition here. And also look at the workspace. I've created a variable called myFun, but it doesn't save, it's not a number, it's not a vector, it's not a matrix. It's actually a function that's being stored as a variable I'm calling myFun. And now I can use this just like I used functions previously, either that I made or that were built into MATLAB. So if I put the number 3 in here, myFun of 3, it returns me an answer. And presumably I want to be able to use this with multiple values of x, but again we see that we have to be careful in our definition to make sure it can handle vectors or matrices if we want to put those in. So here I have that problem that I need a dot caret to be able to use this with my vectors. So now if I rerun this, now it can give me values for 1 and values for 3. And if I want to plot my function, say, let's say between -5 and 5, and let's use 100 values in between there. First, something to point out is that here I'm defining little x as these numbers between -5 and +5, and here I'm defining myFun as having this variable x. Now this is important since I over here said it's at x. It's ignoring any definition I have for little x and treating it as a variable for my function. Whereas if I have something here, say I say a is equal to 8, I can actually put that into this function. Right, so we see here's the difference. X, it ignores that it had a value before because that's a variable in my anonymous function. However, a, which I did define, it's going to use as the number 8 in this definition for my function. Right, and I'll rerun this. So now what I can do is I can evaluate, I'll call y is myFun at all those values of x. And I can plot my x values versus those output values. I can see that's my function plotted from x is -5 to +5, and I see what my values of y are, or what the outputs of myFun are. And just so we can see a little bit better, we can see it with a grid. We can see that this is my cubic function. I can easily edit this to be able to take more than one input argument. So let me get rid of that definition for a, and let me go into here. I can add a as a second argument that my function takes. But now you see what happens is that when we use it later on, I have to supply it 2 input arguments. So I'm going to put in all those values for x. And again, I'm going to, for this example, keep the value of a at 8. I get the same result I had before. However, I can go down here and quickly change what that value is. So instead of 8 times quantity x minus 3, I could say have 5 times quantity x minus 3. And if I rerun my cell, I see that my function is different because I've changed the value of a. And one more time I change the value of a to -2. I can see how that affects my function.